In lesson 6, we took a trip back to Algebra 1 and learned how to factor again, learned how to do the difference of perfect squares and factoring with GCFs. All good stuff that we should remember from ninth grade that we're quickly reviewing. So, number 1, factor the expressions completely. So, factoring is rewriting expressions in terms of products. So, we're writing it as multiplication again. So, this first one, I have x to the fourth minus 81. You have to recognize that as the difference of two perfect squares. Who's going in my front seat? What times itself gives me x to the fourth? Well, x squared times x squared gives me x to the fourth. What times itself gives me 81? 9 and 9, and the difference of perfect squares has opposite signs there. That's why there's no middle term. That's why we have a 0 in that middle term slot there. But is this factored completely? Well, we cannot currently factor the sum of perfect squares. The sum of perfect squares, wait till Unit 3. Yes, Unit 3. So we're going to leave that alone for right now. But x squared minus 9, we can factor that again because it's the difference of perfect squares again. It's x plus 3, x minus 3. So this expression, x to the fourth minus 81, is equivalent to, is the same as x squared plus 9 times x plus 3 times x minus 3. That's factored completely over the integers. This next expression, 9k squared minus 49. Again, the difference of perfect squares. Who's going in the front seat? Well, what gave me 3k squared? Well, 3k did. What gave me 49? 7. And I have a plus and a minus so that there's no middle term. That's all the difference of perfect squares is. Hopefully you remember that from ninth grade. Factor over the integers the expression 12t to the 8th minus 75t to the 4th completely. Well, here's a little story. If you can do this correctly, congratulations, you are smarter than Mr. Hines. This is what he did wrong on his first Algebra 2 trig regions, which is why he got a 99 the first time that I took it. So shame on me. I factored this wrong. Make sure you can factor it correctly. So if you can do this, congratulations, you're a better factorer than I am. Well, we always look for GCF first. What can I GCF out from both of these terms? Well, 12 and 75, what common factors do they have? I can take out a 3. T to the fourth and t to the eighth, well, I can take out 4 of those t's. And what am I left with? Well, what times 3t to the fourth gives me 12t to the eighth? Well, I need 4t to the fourth minus 25. I GCF, I undistributed 3t to the fourth from both of those terms. My mistake was I put a 2 there instead of a 4. I misapplied my properties of exponents, so shame on me. But you should do better than that. Wait a minute. Warning, warning, warning. This is the difference of perfect squares. So I can factor that. GCF comes along for the ride. Who's in my front seat here? Well, 2t squared and 2t squared give me 4t squared plus 5 minus 5. That expression is factored completely over the integers because these are not perfect squares, which is why it's factored over the integers. We'll talk about what that means in the future, but for now, don't worry too much about it. So hopefully you got that right. Congratulations, you're smarter than me. Number 3, factor the expressions completely. You're going to be seeing these directions for about a week now, so get used to, we're going to be factoring things completely. That's always our goal. I have 4x squared times x plus 5 minus 9 times x plus 5. Well, wait a minute. Both of these terms have an x plus 5 in them, so I'm going to GCF that out. That's my GCF there. I'm factoring out that x plus 5. Well, what was it multiplied into? 4x squared minus 9. Good. That's not done yet because what's sitting in front of us right now? The difference of perfect squares. That's 2x plus 3 and 2x minus 3. So the trickiest part here was recognizing that x plus 5 was your GCF. If I asked you to factor 4x squared y minus 9y, you would say, well, coach, take out a y, which is exactly what we did here, but instead of a y, we had this chunk called x plus 5. Over here on the next one, let's see what I can factor out. Oh, they both have a 6x minus 5y. So let's GCF that common factor out. What am I left with? X squared minus 4y squared. Warning, 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 warning. What's sitting in front of us right now? The difference of perfect squares again. So I can factor that as x minus 2y, x plus 2y. Because x times x is x squared, 2y times 2y is 4y squared, and the opposite signs make sure that there is no middle term there. Not too terrible. This is going to be coming up a lot in the future, which is why you have to get used to factoring out these binomial terms. Explain why the expression x squared plus 1 cannot be factored over the real numbers as x plus 1 times x minus 1. Well, let's see what x plus 1 times x minus 1 is. That's x squared minus x plus x minus 1. So x squared plus 1 cannot, well, explain means write a sentence, which is why I'm writing a sentence, cannot be factored as x plus 1 times x minus 1 because that product is equivalent to x squared minus 1, not x squared plus 1. Just as a little side note here, some of you might be saying, well, what if I did x plus 1 squared? Well, what do you get? Well, when I square something, I square the first, 2 times their product, x times 1 times 2 is 2x, square the last. You also do not get x squared plus 1. So we currently cannot factor x squared plus 1 over the real numbers. In Unit 3, we will come up with a way to factor it. It's pretty neat. I enjoy it. So it's currently not factorable over the real numbers. We're going to have to do some work. We're going to have to do some imagining to come up with some way to factor it. That was a good review of GCF and difference of perfect squares. Don't forget them because they're going to be making a reappearance throughout the